Let's take a look at some pre-algebra basics. Excuse me. I guess I better bring up the tablet. There we go. And first thing we want to look at is the opposite of each integer. Well, here we got negative 19. The opposite of negative 19 would be a positive 19. And that's our answer. Now, write the opposite of each integer. So opposite of a 10 is negative 10. So just flip the sign. Now we have some inequality slash equality symbols. Let's review those. Inequality slash equality symbols. We have this one. This is less than. It's read as is less than. We have one that looks like this. That is less than or equal to. We have this one that is greater than. And we have one that looks like that is greater than or equal to. And then we have this one that is equal to. So let's look at some problems dealing with that. So we got positive 2, blank, negative 15. Now if I were to graph these on a number line, clear over here I'd have negative 15, and then somewhere here in the middle I'd have 0, then 1, and 2. So negative 15 is over here, and 2 is over here. Well, the number that's further to the right on our number line, that's the larger number. So 2 is greater than negative 15. So that'd be your answer. And you can think of which one do you have more money with? Or you got $2 in the bank, or you got negative 15. You're overdrawn. Let's look at this one. We've got negative 8 and negative 3. Now, if I were to put negative 8 on number line, it'd be right there. If I were to put negative 3, it'd be right there. Because the way the numbers go is this is like negative 7, negative 6, so forth. Negative 2, negative 1, 0. So if I look at negative 8, it's right here. Negative 5, negative 4. Negative 3 is right here. So negative 3 is further to the right. So negative 8 is less than negative 3. And we got negative 2, blank, negative 2. Well, these are obviously equal. So that one would be equal. Now, next thing we're going to talk about is absolute value. So if we got absolute value, it's indicated by vertical bars like that. And basically it makes whatever's inside positive. So makes whatever is inside positive. So in this one, I have the absolute value of negative 8. Again, makes whatever's inside positive, so this becomes a positive 8. And that's our answer. Let's look at this one. We got the absolute value of 12. Well, makes whatever's inside positive. This is already positive. It's just going to stay positive. It doesn't flip a sign. It just makes whatever's inside positive. And next one are combining numbers. So let me start a new page. There we go. Now some books indicate this as adding and subtracting. I don't like to think of it in those terms. I think of combing numbers. I'll try that again. Combining numbers. And we have two cases of this. Case 1, the signs are the same. They're both positive, both negative. What we would do is we would ignore signs. We would add the numbers. And the sign of your answer is the original sign. So sign of the answer is the original sign. Now we have case 2. This is where signs are different. We would, again, ignore signs. When I say signs are different, one's positive, one's negative. We would subtract the smaller number from the larger number. And then the sign of the answer is the original sign of the larger number. Now we have some shortcuts that help us on these. If you got a positive and then a positive and then a single number, well, a positive becomes positive. So that becomes a positive 3. If you have a negative, parentheses, and then a single number, a negative becomes positive. If you have a plus, parentheses, minus, and then a single number, plus, parentheses, minus becomes a minus. And if we have a minus, parentheses, plus, minus, parentheses, plus becomes a minus. It's easy to remember. If your signs are the same, it becomes positive. If your signs are different, it becomes negative. Well, let's look at some problems here. Now here we got 3 plus 2. And it says combine the numbers. Well, we already know how to do this. 3 plus 2 is 5. So that's our answer. Now, I could use these rules here if I wanted to, but that one we already know. Number 9. We got negative 6 plus negative 2. Okay, we're going to use our shortcut here. We got a positive, parentheses, minus. Positive, parentheses, minus. So that becomes a minus. So we got negative 6 and negative 2. We're combining numbers together. Signs are the same. They're both negative. So the step 1 says ignore the signs. So I'm going to write 6 and 2 over here on the side. Add the numbers. Well, 6 plus 2 gives us 8. And sign of the answer is the original sign. These were originally both negative. So our answer is negative 8. Let's take a look at this one. Got negative 3 plus negative 4 plus negative 8. Well, this first set of parentheses isn't doing anything, so we can drop that. This second one, we got plus, parentheses, minus. That becomes a minus from this shortcut. Plus parentheses minus here becomes a minus. Now, we're going to first tackle the first two numbers, negative 3 and negative 4. Well, that's case 1. Signs are the same. It says you ignore the signs. So we got 3 and 4. Add the numbers. 3 plus 4 gives us 7. Sign of the answer is the original sign. They originally both were negative. So this is negative 7. Well, now we're going to combine these numbers together. We got negative 7, negative 8. It's case 1. Signs are the same. You ignore the signs. So we got 7 and 8. Add the numbers. 7 plus 8 is 15. And sign of the answer is the original sign. They originally were negative. So negative 15 is our answer. Let's look at our 11th example. Sometimes by using your shortcuts, it becomes a problem you already know how to work. Here we have 5 plus, and then beginning parentheses and a minus. Well, up here, plus parentheses minus becomes a minus. So this we rewrite as 5 minus 2 before we do anything. And once we do that, 5 minus 2 is 3. So that's our answer. Okay, so here we have negative 4 plus 12. This is case 2. Signs are different. One's negative, one's positive. This says we ignore the signs, so we got 4 and 12. Subtract a smaller number from a larger number. Well, 12 minus 4 gives us 8. Sign of the answer is the original sign of the larger number. My larger number was 12, which originally was positive. So our answer is going to be positive 8 or just 8. Let's look at this problem. We've got 3 plus negative 2 plus negative 15. Well, here we got a positive parentheses negative. So the signs are different as negative, so that's minus 2. Plus parentheses minus becomes a minus, so that's negative 15. And we're just going to combine numbers together. So I'll start with these first ones here. Three minus 2 is 1, and I'll carry down the negative 15. Well, now we have a positive 1, negative 15. Signs are different. So we ignore the signs. So we got 1 and 15. Subtract the larger number from this, or subtract the smaller number from the larger number. 15 minus 1 gives us 14. And the sign of our answer is the original sign of the larger number. My larger number is 15, which originally was negative. And that's our answer. Okay, let's look at this one. Got 5 minus negative 7. Using our shortcuts, a negative parentheses negative becomes a positive. And once we do that, we know how to work it already. 5 plus 7 gives us 12. Let's look at this one. Got negative 8 minus a negative 12. Now again, no matter where you can apply those shortcuts, you should. Negative parentheses negative becomes a positive. So now we got negative 8 and a positive 12. This is case 2. Signs are different. So we ignore the signs. So we got 8 and 12. Subtract a smaller number from a larger number. 12 minus 8 is 4. And the sign of our answer is the original sign of the larger number. The larger number is 12, which originally was positive. So this is going to be positive 4 or 4. Now number 16. Negative 4 minus a negative 2 minus positive 7. Now I don't think too much about these. I just apply my formulas, my rules. Now here we got a negative parentheses negative. That becomes a positive. So we got positive 2. Negative parentheses positive becomes a negative. So we got negative 7. I'm going to combine these numbers together. I'll start with my first two. They're different signs. So my steps say to ignore the signs. So I got 2 and 4. Subtract a smaller number from a larger number. 4 minus 2 gives me 2. And the sign of my answer is the original sign of the larger number. The larger number was 4, which originally was negative. So we got negative 2 minus 7. Now here we got a negative 2 and a negative 7. So this is case 1. Signs are the same. We ignore the signs. We got 2 and 7. We add them together. 2 plus 7 is 9. And the sign of the answer is the original sign. They both originally were negative. So this is negative 9. And that's our answer. Let's talk about multiplication and division. So multiplication. Now, multiplication and division, you multiply and divide just like normal. The only thing you have to worry about is your signs. If we got a positive number times a positive number, that's going to give us a positive number. If we have a negative number times a negative number, that's going to give us a positive number. If we have a positive number times a negative number, that's going to give us a negative number. And if we have a negative number times a positive number, that's going to give us a negative number. Signs are the same, it's positive. Signs are different, it's negative. Now for division, we're going to divide just like normal, but again our signs is what we're looking at. So if we have a positive divided by a positive, that's going to give us a positive. If we have a negative over a negative, that's going to give us a positive. If we have a positive over a negative, that's going to give us a negative. And if we have a negative over a positive, that's also going to give us a negative. Signs are the same, positive. Signs are different, it's negative. Let's look at this problem. We've got negative 4 times 5. Now, multiplying just like normal, 4 times 5 is 20. We've got a negative number times a positive number. Well, negative number times a positive number gives us negative. So our answer would be negative 20. Let me grab a drink here. Dying. I need to wake up. Okay. Here we got a negative 3 times negative 1 times a negative 8. Now I know this is all multiplication because a number right next to parentheses indicates multiplication. So let's go ahead and multiply these two first. Well, a negative times a negative gives us a positive. And then 3 times 1 gives us 3. And then I'll carry down the negative 8. Now again, we have a number next to parentheses that indicates multiplication. Positive times a negative is negative. And 3 times 8 is 24. Let's look at number 19. We've got 20 over negative 5. Positive divided by negative. Positive divided by negative is negative. And 20 divided by 5 is 4. Now here we got negative 49 over negative 7. Negative divided by negative. Negative divided by negative is a positive. And 49 divided by 7 gives us positive 7, or just 7. Let's talk about something called exponents. And let me scroll down a little bit here. If I got, for example, 2, and then something looks like that. Number smaller, and it's kind of set up like that, that's your exponent. It's read 2 to the 3rd power. What that means is we're going to take 2 and multiply it times itself 3 times. Again, your exponent, your power here, tells you how many of these you're going to have. Well, 2 times 2 times 2 gives us 8. Number 21. We want to complete this table. They say exponential notation. Oh, I already did that one. 2 to the 3rd. Then it says factor form repeated multiplication. So factor form, well, that's our 2 times 2 times 2. And then our standard form over here is you go ahead and multiply them together. 2 times 2 times 2 is 8. And those will be our answers. Now let's look at our next one. Number 22. Okay, so they're giving us the factored form. So we got 4 3s. Now parentheses right next to each other indicate multiplication. Dots right next to the, or between two numbers, indicates multiplication. Well, exponent-wise, there's 4 3s, so this is going to be 3 to the 4th. Now our standard form, 3 times 3 is 9, times another 3 is 27, times another 3 is 81. So that'd be 81. So these would be our answers for that one. Now for number 23, they give us our standard form, which is 27. Well, think of what number multiplied together to give you 27. 2 times 2 times 2 is 8, times another 2 is 16, times another 2 is 32. That doesn't work. I go to my 3s. 3 times 3 is 9, times another 3 is 27. Well, that'd work. 3 times 3 times 3 would give us 27. And that's 3 3s, so that'd be 3 to the 3rd power. And those will be our answers. Oh. Shifting my seat here. Now the next thing talks about scientific notation. So let's let me start a new page and we'll talk about that. Scientific notation. Now scientific notation means you got a single digit here and a decimal, and this digit here should be the numbers between 1 and 9. So you can have 1 there, you can have 2 there, you can have up to 9. Can't have 10, can't have 11, can't have 0. And then we'll have some more decimal places over here, times 10 to some power. That's our scientific notation. So let's look at this one. Number 24. Got 70,100. Now I'm looking for my leftmost digit that's not a 0. My leftmost digit that's not a 0 is a 7. So we want this to be 7 point, and then I'll write the rest of these down. So I got 0, 1, 0, 0. We'll come back to this because we want to modify that a little bit. And then we want that times 10 to some power. Well, if I were to put a decimal place, it'd be right here. So to get it over between the 7 and the 0, I'm going to move it 1, 2, 3, 4 places over. Now this is either going to be to the 4th power or to the negative 4. In this case, it's to the 4th power. When you're going from standard form to scientific, and you move your decimal 4 places to the left, it'd be a positive 4. If you move it to the right, it'd be a negative 4. Way to remember this. This is kind of a big number, isn't it? 70,100. 10 to the 4th, that's a big number. 10 to the negative 4 would be a very small number. Now that's kind of a vague way to remember it. We used to have a chemistry instructor here. That's how she used to teach it. My wife learned it that way, and I thought that's not too bad for a very easy way to try to remember it. If you don't got a memory. Okay, let's look at this one. We got 0.0724. I want my leftmost digit. Oops, I forgot on this one. We're supposed to drop off any trailing zeros. So this would be 7.01 times 10 to the 4th. So that's our extra answer. Sorry about that. I'll wake up here eventually. There you go. Now here. I want my leftmost digit that's not 0. Well, that'd be 7. So we want to write this as 7.24 times 10 to some power. Well, here's my decimal. To get it between the 7 and the 2, I need to move it 2 places to the right. And this would be -2. So that's our answer. Again, this is a very small number, and 10 to the -2 is a small number. So let's look at the next one. Got 2.31 times 10 to the third. Now 10 to the third is 10 times 10 times 10, which is 1,000, which is kind of a big number. So we want to take this from scientific notation and write it into our standard form. Well, if I put my 2.31 down here, 10 to the third we said is a big number. If I move my decimal 3 places to the left, that'll be a very small number. So I want to move the decimal 3 places to the right. So there's 1, 2, 3. And that's where we want to move it to. Now when we moved it, there was no digit here, so we had to put a 0 in there. So our answer is going to be 2,310. Let's take a look at this one. We've got 5.2 times 10 to the -4. Well, this 10 to the -4 is a very small number. If I move my decimal to the right, I'd have 4 places. I'd have a very big number. So that tells us which way we're going to move this. So we're going to move our decimal point 4 places to the left. So 1, 2, 3, 4. And again, I had to put zeros here for those missing digits. So our answer is going to be 0.3052. Now the next thing is best to show with a couple examples. Oops. So let's take a look at that. It says determine the square root of each. This symbol right here is the square root. Now what we try to do is we try to write the prime factorization of whatever numbers inside there down. Like 4 is 2 times 2. Now when we're talking about square roots, we're looking for pairs of something. Pairs of numbers, pairs of whatever. Well, here's a pair of 2's. So that pair of 2's is going to come out in front as a single 2. So our answer would be 2. Next problem, we got the square root of 25. Well, 25 is 5 times 5. Remember what I said, we're looking for a pair of somethings. Here's a pair of 5's. A pair of 5's is going to come out in front as a single 5. And that'd be our answer. Yeah, I'm starting you. Now, the next topic we're going to talk about is order of operations. And there's a cute little saying. Do you remember this? Please excuse my dear Aunt Sally. The first letter of each word tells us what to do. It stands for PEMDAS. So the please, that tells us to do what's inside of the parentheses. So P stands for parentheses. That doesn't necessarily mean get rid of parentheses. That says do what's inside the parentheses. The E stands for exponents. Now the my dear, M and D stands for multiplication and division. So you'll multiply or divide as you encounter either one from left to right. Now this does not say you go through and do all your multiplication and then you do all your division. It says you do either one as you can count it from left to right. And the A and S stands for add or subtract as you can count it from left to right. So add or subtract as you encounter them from left to right. And let's try it again. As you encounter them from left to right. So let's use those to solve these next problems. So we got 5 plus 3 divided by 4. Please excuse my dear Aunt Sally. Please says do what's inside the parentheses. Well, what's inside the parentheses here is 5 plus 3. So that gives us 8. Now in this case I can actually drop those parentheses because they're not doing anything anymore. Please excuse, there's no more parentheses, there's no exponents. My dear, there is division. 8 divided by 4 gives us 2. And that's our answer. Let's take a look at this one. We got 3 times 15 minus 5 plus 4. Please excuse my dear Aunt Sally. That says do what's inside the parentheses first. So I'm going to have 3 times 15 minus 5 gives us 10. Now carry down everything else. Now those parentheses I dropped because they're not doing anything anymore. Please excuse. There's no exponents. My dear, multiplication, division. Well, here's multiplication. So 3 times 10 gives us 30. And I'll bring down to plus 4. Aunt Sally, addition or subtraction. Well, here's addition. 30 plus 4 gives us 34. And that's our answer. Let's look at one more of those. We got 8 minus 21 divided by 3 plus 2. Please excuse my dear Aunt Sally. There's no parentheses, so there's nothing to do inside of parentheses. Excuse, there's no exponents. My dear, multiplication or division from left to right. Well, the only division I have, or multiplication, is that right there. So 21 divided by 3 gives me 7, and everything else carries down. Aunt Sally, addition and subtraction. Well, first one here is 8 minus 7, which gives us 1. And then 1 plus 2 gives us 3. Let's take a look at evaluating expressions. It says use substitution to evaluate these expressions. A is equal to 3, B is equal to 4, and C is equal to 2. And we got 5a squared. This is evaluating expressions. I cannot spell. You should have better than that. There we go. Evaluate expressions. Step 1. Replace variables with parentheses. So replace variables with parentheses. Everything else remains the same. So the 5a squared, I'm going to replace the a with a set of parentheses. So we got that. Plug, step 2, plug in the appropriate number inside the parentheses? Well, this one we had a there. A up here we said was 3. So we're going to put 3 inside the parentheses. Wouldn't make any sense to put 4 in for the b because there is no b. And step 3, simplify using your order of operations. Please excuse my dear Aunt Sally. Please, there's parentheses, but there's nothing to do inside of the parentheses. Again, that doesn't mean get rid of the parentheses. That says do what's inside the parentheses. Please excuse exponents. We have 3 squared. So 5 carries down. 3 squared is 3 times 3, which is 9. My dear, multiplication division. So 5 times 9 gives us 45. And that'd be our answer. And I'm going to start a new page because I'm about out of space. Okay. So A is 3, B is 4, and C is 2. Then we got ABC minus C squared. And we want to evaluate these expressions. Well, first step is go through and replace all of our variables with parentheses. So I got parentheses, 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 minus parentheses squared. Now notice everything stays the same. The minus is here, the second power. We just replace each variable with a set of parentheses. And this is A times B times C, so these parentheses next to each other indicate multiplication. Now plug in an appropriate number. We said A was 3, so everywhere we had an A, we'll put in 3. B was 4, so everywhere we had a B, we'll put in 4. And C is 2, so everywhere we had a C, we'll put in 2. Okay, order of operations. Please excuse my dear Aunt Sally. Please. There's nothing to do inside of parentheses, so we're fine there. Please excuse exponents. 2 squared. So let's do that. All the rest of this carries down. 2 squared is 2 times 2, which is 4. Please excuse my dear multiplication division as you count it from left to right. Well, here's my first multiplication or division. 3 times 4, which gives us 12. And I'll carry everything down. My dear, I'm still doing multiplication division. Well, here's another one. 12 times 2 gives us 24. Aunt Sally, addition and subtraction. 24 minus 4 gives us 20. And that's our answer. Now these next problems are solving equations. And basically we're just given ones with decimals. And I'm going to show this a different way than I sometimes do, so to get you thinking along those lines. So let's take a look at 35. We got x plus 3.2 equals 70. Now you can think of, with equations, your goal is to get the x by itself. And so to get the x by itself, I need to get rid of this 3.2. Well, this is plus 3.2. Well, if we do the opposite operation, opposite of plus is minus. So if we subtract 3.2 from both sides, then we'd get our answer. Now 3.2 minus 3.2 drops away, and we got x is equal to 66.8, I believe, when you plug that in your calculator. Now another way of thinking of this one. We got x plus 3.2 is equal to 70. You can simply take the number over to the right side, and anytime you take anything across your equals, the sign changes. So it becomes a negative 3.2. And then 70 minus 33 or 3.2 gives us 66.8. That's another way of thinking of it. Let's look at our next problem. X minus 7 equals 32.1. Okay, now we want to get rid of the minus 7 there. So that's subtraction. That's minus 7. So we'll do the opposite operation, which is plus 7. Well, negative 7 plus 7 cancels, and we got x. And 32.1 plus 7 gives us 39.1. And that's our answer. Now, the other way you can think of it, one I just talked about up above, we want to get x by itself, so I'm going to take that negative 7 and just move it over to the right side. Anytime you move anything across your equals, the sign changes. So negative 7 becomes a positive 7. And that gives us 39.1. Let's look at this one. We got negative 3.2x equals 16. Now always, if you got a number in front of your x like this, how you get rid of that is you divide both sides by that number. So we're going to divide both sides by negative 3.2. When we do that, these negative 3.2s will cancel. Where's my calculator? I'm not going to do it by hand. 16 divided by 3.2. That gives us 5. Now, positive divided by negative is negative. So our answer is negative 5. And our last problem. We've got x over 3 is equal to negative 2.1. Now, the opposite operation. Right here, this is the opposite operation here. This is negative 3.2 times x. So we divided by negative 3.2. Now over here we're dividing by 3, so the opposite operation is multiplying by 3. So we'll multiply both sides by 3. Now when we do that, these 3 is going to cancel. X equals, positive times a negative is negative, and 3 times 2.1 gives us 6.3, I believe. And that would be our answer. And the end of that unit.